Hi, welcome back all dear students. Today we are actually going to continue the module under the quantitative ability area called arithmetic. In the arithmetic module of quantitative ability, we have had multiple sessions already. We have had 2 sessions. Today we are going to have the concluding session, 3rd session in this particular module of arithmetic. In the first module, you would have done the fundamentals of percentages and profit loss discount. In the second chapter, second session of arithmetic module, we have done simple interest, compound interest, and basics of ratio and proportion. So these are the different topics that you have done. Today we are going to continue this particular module and do 2 new topics under the module, and those are averages and then mixtures. These are 2 very important topics that we are going to counter with respect to CAT and MBA entrance exams. And we are going to learn a very interesting method called alligation under averages, which is very powerful technique to solve lot of average problems in a very easy manner. And as opposed to the other commercial mathematics topics that you would have done in childhood, like profit loss discount, like simple interest, compound interest, like time speed distance, averages and mixtures is one topic I see many students are not so comfortable with because they did not counter this a lot in high school. They have done a little bit of it but not so much. So it's important for you to put lot of effort on this topic, because we see this particular topic is not just tested in quantity ability. Lot of times an application of this comes in your LRDI, data interpretation and logical reason, as we discussed in an LRDI section. So it's important for you to kind of ensure these topics are well learnt, well understood, well practiced. So without much delay, without much ado, let me actually kind of get started with the topic. We'll go ahead and try to first understand the concept of averages, etc. and before we do some interesting problems and learn some nice shortcuts. As always in my class, I suggest you to make very serious notes on everything that I write on the board, because even though you don't understand something 100%, which is not the goal of the class, you can go back and revise the notes, retain the notes. That's very important. So let's go ahead. Let's have a great day. So this is one of my favorite sessions in quantitative ability of CAT. So let me first get started with, let me ask you this question, right? You would have all known the concept of average. Average as a concept is so very well known that any of you can tell me what is the average of, what is the definition of average, etc. One important thing that you ought to know is average is actually, why do we need average? What is the application of average? First we need to understand that before we know the formula or method. You should know that I get calls every now and then from students asking me, should I choose X college or Y college, etc. I had a student called Karan calling me, asking me, sir, I got an IIM Bangalore final admission and IIM Calcutta final admission. How do I choose whether I have to choose IIM Bangalore or IIM Calcutta? Now these are the kind of questions many of you are going to doodle with once you are done with your CAT, get a percentile, do your GDPI, and then finally get an admission. Now how do you make a choice between X college and Y college? You look at many factors: faculty, library, infrastructure, networking, location. But one of the factors that you all are going to look at, which is more important for you, which is not good actually, but which is more important for many of you, is what is the salary that I get in IIM X and IIM Y. And you don't go to the college and ask, when you ask what is the salary you get, the college gives you a figure called average salary. They don't give you a figure called higher salary or lower salary, because for you to measure what is the overall quality of a college, we talk about average salary, average packet. As compared to the average packet and another salary, you respond. So average is basically a measure of a group. Average is a single measure of any group. I also use this statistic a lot with respect to faculty. A lot of faculty, when we are there at Abhyaas, what happens is when there's a faculty who is going into a batch for the first time, they obviously get a sense from the other faculty who have done classes for the same batch, which is very important for us. We'll ask, what is the batch like? On a scale of 10, what is the batch like? What is the average level of the batch, ability, aptitude of the batch? If I say a batch like yours, if I say is a 7 out of 10, oh, that means it's a very good batch. I can have a reasonably good speed and I can do little more tricky problems. As opposed to if I'm doing a batch which happens to be a 4 on 10. What happens? The faculty automatically need to readjust their speed, readjust their levels of problem that they need to do. So average is basically a measure of a group, an absolute, a single measure of a performance of a set of group. That's extremely important. So this is an application that you have. We talk about average growth rate of India. We talk about average population India, average per capita income. A lot of these things are based on the simple mathematical concept called average. And if I ask you what is the mathematical, now that we understand the concept, how do you kind of mathematically define or make a formula? As we know, average of any group of observations, any group of quantities is very simply sum of all the quantities x1 plus x2 up to xn divided by number of quantities. Sum by number. This is what is the most popular formula for average. Sum of the observations by number of observations. Right? This is something so very simple that you have been knowing from your childhood. Not a big deal. Not a big deal at all. Right? And this is the application that you have. Today I don't think this is a good method. For example, let me kind of ask you, let me give you a situation of a student who has actually scored these marks in the 6 subjects in a 10th grade, right? He got a 90 in first language, he got a 94 in second language, he got a 77 in the third language, he got a 100 in math, he got a 98 in science, he got a 96 in social. Now if I ask you what is the aggregate score, what is the average percentage score of this student, because each subject is for 100%, what is the average score of the student in a subject on this? Now the regular method that you all have is, I don't know, you can already do number crunching, 90 plus 94 plus 77 plus 100 plus 98 plus 96 divided by number of observations 6. But I wanted to give you a shortcut, a better shortcut whenever you have a situation like this of finding an average. After today, you would never ever apply the formula called x1 plus x2 plus x3 so on up to xn divided by n. No, that is not the formula. Let us learn a shortcut. This is not a good method. What is the shortcut? That shortcut is called deviation method. Please notice, deviation method is a very, very useful, impactful trick of doing averages pretty quickly, pretty orally. You need not put a lot of pen and paper. Let me tell you how. In a deviation method, what you do is basically looking at the observations, you assume an average. First, you assume an average. For the final average, what I'm saying is you assume an average called A bar, assumed average. And then you only look at what is the deviation of each observation from this assumed average. Let me, for example, take the same question. In the question 90, 94, 77, 100, 98 and 96, because all of them are very close to 90, if I take, hey, because most of them are close to 90, why don't I take the initial base as 90? You can take the initial base as 20, 30 again. But taking the base as close to as the middle number possible in the given numbers will help you decrease the deviations. If I assume A bar in this case is 90, that is the base average I have taken is 90, after that I only look at deviations of each number. For example, first subject deviation from 90 is 0, second subject deviation from 90 is plus 4, third subject deviation from 90 is minus 13, fourth subject deviation from 90 is plus 10, fifth subject plus 8, sixth subject plus 6. What is the advantage of this method? This method now makes it very easy. Unlike earlier times, you can do the sum orally, very orally. 0 plus 4, 4, 4 minus 13, minus 9, minus 9 plus 10, plus 1 plus 8, plus 9 plus 6, plus 15. So, overall deviation of these 6 subject scores from the assumed average A bar of 90 is 15. Automatically what happens after this, for me to find the final average is nothing but the A bar plus or minus the deflection, right? Whatever the deflection. Only thing is, because the total deflection is 15, what is the deflection equal to? Plus 15 divided by subjects. Total deflection is 15. For each subject, what is the deflection? It will become plus 2.5. Because the deflection is 2.5, more than, so hence the final average in this case is very simply 90 plus 2.5, Hence, the aggregate score of this student is 92.5. So this is how quickly you can do this. Quickly make a note of this. And by the way, you might ask me, how do I know this percentage and stuff? By the way, this is my score back in my SSC many years back. I was a state topper at that, one of the state toppers, state 9th rank. But why am I saying all this? It is because it helps you. Please understand, this method helps you find the average pretty quickly. So wherever from now onwards, particularly in data interpretation, you might have a lot of questions where you need to find the average. Please don't apply the classical method of x1 plus x2 plus x3 up to xn divided by n, but use the deviation method. Very, very, very important. Quickly make a note of this before I go further. Right. Now, let me kind of take you to the second concept, which is related concept called weighted average, which is also very similar. The only difference being, unlike the regular average, in a weighted average, the weightage of each observation, weightage of each quantity could be different. In the earlier case, for example, x1, x2, xn, all of them have uniform weight, 1, 1, 1, 1. Hence, the denominator also is 1, 1, 1 plus 1 plus 1 n times n. But in the context of weighted average, what happens is sometimes the weight of one observation could be higher than the weight of the other observation. Let me kind of tell you this way. In your some of the exams, the weightage of one section could be double the weightage of the other section. Then the average will no more be regular A is equal to x1 plus x2 up to xn, but it will be something like this: w1 x1 plus w2 x2 weight into the value, and finally w1 xn divided by, it would now be not just sum of number of observations but sum of the weights, w1 plus w2 plus w3 up to wn. This is called weighted average. The only difference is, in the regular average, the weight of each observation is equal. Hence, if you put what 1, 1, 1, you will get the same formula. Now, this is one important thing that you ought to know. You ought to know. And you might feel, sir, I mean, we have learned a shortcut for average, but how do we do weighted average? Do I again need to use the same formula? No way. I don't want you to use this. I don't want to use this at all. We can actually do this weighted average also in the same context as your deviation method. You can apply the deviation method in the exactly same way. We can do this in the same way. It's a very, very powerful method. It's a very, very powerful method. Now let's see, how do we do this? How do we do a deviation method? Let me take an example. Assume in a group there are 10 people who have, say, 8 chocolates each. The 10 people in a classroom with 8 chocolates each, right? And then you have say another 2 people. There are another people. The 2 people who got, say, 10 chocolates each. The moment I have this, the question is, what is the average number of chocolates that the person can have? Don't worry if it's going to be integer, non-integer, doesn't matter. The question is, 10 people, 8 chocolates, and 2 people, 10 chocolates. What is the average number of chocolates, if I ask you, per person? One way to do it for you is, 10 into 8 plus 2 into 10 divided by W1 plus W2. Here weight is because the number of chocolates, average number of chocolates you are asking, X will be chocolates and W would be people. So 10 into 8 plus 2 into 10 divided by 10 plus 2 and so on. You might say, sir, the formula is simple, why don't we apply that? But if I assume there's another group of people, another 3 people assume had 14 or say 16 chocolates each, then the problem looks a little tedious. It doesn't look any more easy. 10 people, 8 chocolates, 2 people, 10 chocolates, 3 people, 16 chocolates. This can be any group. So how do you do the average? I don't want to apply the formula. I can apply the deviation method again. What do I do in the deviation method? Exactly similar. First I assume an A bar, assumed average. Because I'm trying to find average number of chocolates, assume an A bar, average number of chocolates with them. One of the group has 8, one of the group has 10, other group has 16. Take a number which is nearest. Hey, why can't we take a number like 10? Assume if I take a number like 10, middle number. If I take A bar is 10, let us see the first group of 10 people, the second group of 2 people and the third group of 3 people. Let us see the deflection. The good thing about taking 10 is one of the group the deflection can become 0, right? First group of 10 people, they have 8 chocolates, but the assumed average is 10 chocolates, hence minus 2 is a deflection per person. And the second group, the deflection is 0 because assumed 10, they have 10. Third group is 16, so deflection is plus 6. The only difference, till this the method is same. The only difference is earlier the deflections were straightforward added. You can't add them straightforward here because you have a weight component. What is the weight? Each person has a deflection of minus 2. So 10 people overall have a deflection of minus 20. 0 deflection into 2 people, 0. 3 people, deflection of plus 6 will become plus 18. So the net deflection is now add on all these, total deflection will become how much? Minus 20 plus 18 is minus 2. Automatically, what can I confidently say? The confident thing is average chocolates or we can say from this, what I can say? Average chocolates is equal to A bar plus or minus deflection. So it is equal to 10 that we have assumed. And what is it? Because the total deflection is minus, it can be written as minus 2, but it is not, again as I told you, it cannot be just, this is total deflection, hence total deflection by sum of weights here. Earlier it is some number of observations. Sum of weights here is 10, 2 and 3, 10 plus 2, 12 plus 3, 15, minus 2 by 15. So 10 minus 2 by 15 or 10 minus 1 by 8, approximately 10 minus 0.25, it's approximately 9.8. So each person has how many chocolates? 9.8. So even weighted average, you can do the same logic of, deflection method. So please make a quick note of this. You will understand how powerful this is once we do some. This is very useful. You can apply this logic in every question that you get with respect to your questions in weighted average and this thing. Please make a note, quick note of this. After you make a note of this, try question number 1 to 3. 1, 2, 3. I'll give you 4 minutes. Just try question number 1, 2 and 3. I'll give you 4 minutes. Don't disturb your friends. Please focus on your problems and make notes. Keep thinking. If you have not found one part of my explanation clear, keep thinking. It will become easier. Right. I think we have given enough time. Let's get started with the problems now. These are all very simple, straightforward, easy problems, except for the first question is very nice. Let's look at this. Let's start with the question number 1. Let us look at this carefully. Let us see what do we have in question number 1. Question number 1 is a little interesting. It's different from the straight away problem that we have learned. We have 5 weights and we don't know the weight of each of the box. But what do we know for sure? We know that when they are weighed together, 2 at a time, you know the whatever weights have come. 2 things at a time in pair, we know the weights and we have got some numbers and what is the weight of the heaviest box. The moment you saw this, a lot of people the too many numbers, too much of data given, and how do we connect it? Never ever worry about getting an answer. First try to conceptualize a problem in CAT. That's very important. Assume if the weights of the boxes are A, B, C, D and E. There are 5 boxes, the weights be A, B, C, D, E in the same order. Assume A is the smallest weight, B is the second smallest weight, etc. You assume. So middle weight obviously is the C. Highest weight is E and A is the lowest weight and so on. Can you automatically decide? Based on this, can we say what would A plus B? Because each pairs A plus B, A plus C, B plus C, C plus D, E plus E and all that is given. Because 5 weights are there, 5 boxes are there, paired 2 at a time, how many such pairs will be there? A can be paired with B or C or D or E 4 times. Like that total pairs 5C to 10 pairs will come. Say for example A plus B, A plus C, B plus C, so on. The highest weight is D plus C. One thing that we confidently can say is that we don't know what are each weights corresponding to. For example, 115 corresponds to what? B plus C, C plus D. I can't say all that. But one thing for sure is, in the weights that have been given as a pair, the lowest pair of weights, because A and B are the lightest weights, A plus B has to be the lowest value, which is automatically 110. That can be confidently said. And similarly, the highest value has to be the highest 2 weights, and hence I can confidently say D plus E is 121. That can be confidently said. And what about the second highest weight? Second highest weight comes when the lowest possible weights are added. That means A still should be there, and the next second lowest weight possible after B is only C. So A plus C also we can confidently say as 112. Similarly, if I look from the highest side, highest weight E should still be there, but the second highest possible after D would be C, hence C plus A is automatically 120. But can we say anything about numbers in between? I don't know. It could be A plus D, B plus C, B plus E. We can't say. All this is question mark. Which one is what? So after we know this, but what is the next method? Because the question is finding E. For me to find E, I need to can I do a sum? If I do the sum, let us see what happens. Here is where we can apply our deflection method. If I add all this, for a minute, think of if I add all this, what happens? Right hand side and left hand side. Add all this. If I add all the things on the left hand side, A plus B, A plus C and so on, we know each weight called A, B, C, D comes how many times? A has to come with B, with C, with D, with E. So A will come 4 times. Similarly, B will come 4 times, C will come 4 times and so on. Hence we can confidently say the left hand side will become equal to 4 into A plus B plus C plus D plus E. While there is no average in this question, I have the sum of all the weights in pairs. That means each weight, each box by itself is coming how many times? 4 times in the sums. Can I do the other side? Just addition. Deviation method is not just to find average. Deviation method is a shortcut to find sum. Don't waste your head on adding all the things. Because each of them, 110 is the lowest value, 121 is the highest value. Why don't you quickly say, assume, start the deviation, start with 110. Give 110 to all of them. And 10 such pairs are there. So sum of the things will be equal to 10 into 110 for sure, plus this is the base. For each you are assuming 110. So 10 into 110 plus deviation method. After that only the addition of extra deviation we have. Now 110, first one deviation is 0. Second one it is 2. 0 plus 2, 2. Third one it is the 3. 2 plus 3, 5. Fourth one 5 plus 4, 9. Fifth one 9 plus 5, 14. Next 14 plus 6, 20. 20 plus 7, 27. 27 plus 8, 35. 35 plus 10 now, 45, 45 plus 11, 56. So if you can see, after giving 110 to each number, you just have deflections. Like I'm just making a note here for those who are not able to follow, something like this. You can say you have to add all of them. All that can be orally added to get what? 56. And the moment I have this, is it not very simple? I can find A plus B plus C plus D plus E. This should be automatically equal to 10 into 110 will become 1100 plus 56 divided by 4. Now 1100 divided by 4, whenever you have to multiply, divide something by 4, that into 100 by 4 can be 25, hence 11 into 25, that will be 275 plus 56 by 4 is 14. This is 14, that means the sum of all the weights taken one time is 289. But still the problem is not over, sir, because once after this you can find anything. Can we find all the weights? Yes, I can find all the weights uniquely using this logic. Why? Because I can find lowest weight sum. I know A plus B, I know D plus E, I don't know C separately. A plus B is 110, D plus C is 121. But all three of them added will become equal to 289. Can I find C from this? Absolutely. C is equal to 289 minus 110 minus 121. That is nothing but 289 minus 231, which will become 58. That means middle weight is 58. And the moment I know middle weight is 58, but the question is not about middle weight, it is asked about heaviest box. After this it's a matter of substitution. Because second highest weight is 112, 112 is nothing but sum of the lowest plus middle weight. So 58 plus something is 112, that something A will automatically become 112 minus 58, which is nothing but 54. Similarly, I can find the highest weight, which is what is asked. 58 plus something is 121, what is that something that you have? That's what is asked, isn't it? So this is how you can do this. The moment I have this C, by the way, C plus E is 120, what would that highest weight be? 120 minus 58 is 62, and from that you can similarly find D plus E is 121. 62 plus D is 121. What would D become equal to? It will become equal to 59. Similarly, A plus B is 110. 54 plus B is 110. It will become 56. So all 5 weights are known uniquely. And because the question is about the highest weight, hence the highest weight, heaviest weight is 62. But which is easiest to find? Middle weight is the easiest to find. So this is a very, very important problem. Please make a quick note of this. This is not a direct average question, but you see how deflections can be applied. I'll give you a minute. Please make a note of this.